Acceleration can be defined as the change in velocity over time. So we studied the displacement and we said change in displacement over time is defined as the velocity. And in the same manner, the change in velocity over time is called acceleration in physical and mathematical terms. When you are driving your car down the road and you're driving on 30 miles per hour or 30 kilometers per hour, then you increase the speed to 80 kilometers per hour. That time you took to move from 30 miles per hour or kilometers per hour to 80 kilometers per hour, that is called acceleration. So if you want to define the equation of acceleration, as we said, acceleration is the change in velocity over the change in time. Again, acceleration is a directional unit. It could be negatively annotated value or positively annotated value in a similar way to what we discussed about velocity. And the negative sign in this case is representing the direction of acceleration. As well, it's worth to mention that when you see a negative value for velocity or acceleration, either it means an indication to the convention. So if you move to the right in velocity or in acceleration, that's a positive value. If you move to the left, that's a negative value. It could be as well if you are increasing your velocity, that's a positive value. If you decrease velocity, that's a negative value. Same manner for acceleration. If you are increasing your acceleration, that's a positive value. Deceleration or decreasing the value of acceleration, that could be a negative value. And the time is a non-directional value, as we know. In more simpler terms, acceleration equals the change in velocity divided by the change in time, which can be represented as v final or final velocity minus vo or initial velocity or v naught over the t final, which is the final time, minus the t naught or to, which is the initial time. So we use the acceleration equation to be able to derive the units of acceleration. So we know that in the simplest form, acceleration A equals v over t, velocity over time. What is the units for velocity? That's distance over time, or like a certain distance unit per time, let's say meters per second, or kilometers per second, kilometers per hour, or even miles per hour, miles per second, and so on. And time is represented as a time unit, let's say in seconds. If you do mathematical simplification for this, it will be distance over time squared, which means a unit of distance, in this case could be meters, over a unit of time, which could be seconds squared. So acceleration equals velocity over time. Just for simplification, velocity multiplied by 1 over time. Same thing, it's velocity over time. Now, what is the units of velocity? Let's say we're talking about units of meter per second over here, like everything is in metric units. Velocity was meters per second, so can be said as meters over second multiplied by 1 over what is the units of time? Seconds in this case. So it will be meters multiplied by 1, that's meters, and over seconds by seconds, that's seconds squared. So that's how we came up with the units of acceleration. Same as in velocity, we have average acceleration and we have instant or instantaneous acceleration. Any moment that you measure the acceleration equal velocity over time at that exact moment would be instantaneous acceleration. But when you have the acceleration in this form, acceleration with this sign means average acceleration. The equations that you saw earlier represents the average acceleration in most cases. So what you're doing here, you're taking an average. So final velocity minus initial velocity over final time over minus initial time. And that would give you the average acceleration. But if you want instantaneous acceleration, let's say you have a car moving and at a certain time you stop the time and you took what your stopwatch is saying, let's say 5 seconds, and you divided the velocity of the car at that moment over that exact time, that will give you instant acceleration. And this would give you the average acceleration. Let's take an example. So there's a car going from 0 to 60. What is the acceleration? For simplicity, let's say the car is going from 0 to 60 meters per second, and it is taking 6 seconds to do that. What is the acceleration? In this case, acceleration is the change in velocity over the change in time. Initial velocity was 0, that's V naught or VO, and the final velocity was 60 meters per second, and the final time here is 6 seconds, and of course initial time was 0. So plug in the numbers, V final minus V naught, so let's write it for your reference, V final minus V naught over T final minus T naught. That would give you 60 minus 0 over 6 seconds minus 0. That would be 10 meters per second. As simple as that. Let's take another example. So you have a hybrid car with an initial velocity of 10 meters per second east. It means it's going east. It's a positive value. That's what you understand from that. So that's the V naught or initial velocity. It accelerates at 3 meters per second squared. So he said it accelerates, that means this is the acceleration. And from the units as well, you can know it is an acceleration to the east, so it's a positive value. How long will it take the car to reach the final velocity of 25 meters per second east? So the final velocity is here, and how long it will take, it means he's asking about t, which t, how long it will take to reach the final velocity, so he needs the final time, so t final in this case. Let's break things down. Firstly, what equation we should use in this case? Of course, acceleration equals delta v over delta t, which means I need v final and subtract it from v initial over t final subtracted from t initial. In this case, what is your initial time? Initial time in many cases could be 0 unless otherwise mentioned in the question. So in this case, v final is right here, 25 meters per second minus v initial, he said 10 meters per second, over t final, that's what we're looking for, minus t initial is 0. That would equal the acceleration. How much is the acceleration? 3 meters per second squared. So let's prepare things a little better. So 3, which is the acceleration, equal 25 minus 10, that's 15, over t final minus 0 can be represented as t final. So 3 over 1, do cross multiplication over here. It will give you 3 t final equals 15. Divide over 3 for both sides. So in this case, t final would be 5 seconds.